Hello everyone, welcome to Engineering Explained channel. In this session, I am going to discuss the hydraulic cylinder calculations. The hydraulic cylinder calculations such as force, velocity and power. In the double acting cylinder, during its extension stroke and during the retraction stroke, the force acting by the piston are different, and those are depend on the area on which the fluid pressure is acting. Then the velocity during the extension retraction are also different. Therefore, the power producer those are also different. And here I am going to discuss how these parameters cylinder force, velocity and power are to be calculated for the extension and retraction stroke of the double acting cylinder. I am going to discuss. In hydraulic cylinders, force is calculated by pressure multiplied by the piston area, and velocity is determined by fluid flow and piston area, and power is the product of force and velocity or pressure and flow. Force first will take force F is equal to pressure P multiplied with the area A. The force that hydraulic cylinder can exert is directly proportional to the pressure of the hydraulic fluid and the effective area of the piston. Here, two pressures will be acting during the extension stroke. The pressure will be different, and during the retraction stroke, the force will be different. First, we'll take for the extension stroke. The F extension in Newton is given by pressure multiplied with the area. Pressure P in Pascal multiplied with the area of the piston in meter square. And this area of the piston is given by during the extension stroke entire piston area AP is subjected to fluid pressure. During the extension stroke the entire the piston area on that the fluid pressure is applied. Therefore that area is taken. Okay, that is the active area on which the fluid pressure is acting, and that F extension we can determine during the extension stroke. For the retraction stroke, the F retraction in Newton is equal to pressure in Pascal multiplied with the AP minus ER in meter square. And during the retraction stroke, here the cylinder rod will be there, and this rod on that there is no pressure is acting. The annulus formed by this cylinder as well as this cylinder rod, on that only the fluid pressure is acting. Therefore, whole piston area subtracted with this rod area we have to take. There is AP is a piston area, AR is a rod area. During the retraction stroke, annulus area AP minus AR is subjected to fluid pressure. Okay, that F retraction we can determine. Example, if a cylinder has a pressure of 10,000 psi and a piston area of 5.1 square inches, the force would be 51,000 pounds. And that F is equal to 10,000 psi multiplied with a 5.1 square inch, that is equal to 51,000 pounds. And similarly, here the for the extension and retraction stroke, the area of the pistons to determine the velocity, the similarly we are going to consider the force per area we need to take there, and there the area for the extension will be AP we are going to take the same here for the extension what we have taken, and retraction AP minus ER we are going to take while calculating the velocity also. Velocity is the rate at which the piston moves, which depends on the flow rate of the hydraulic fluid and the area of the piston, or the piston area minus the rod area during retraction. During extension stroke, V extension is equal to flow rate Q by piston area AP, and V extension in meter per second is equal to Q in meter cube per second by area of the piston in meter square. And during retraction stroke, V retraction is equal to flow rate in Q by piston area AP minus rod area AR. That V retraction in meter per second is equal to Qn in meter cube per second by AP minus area in meter square. Example, if a cylinder has a flow rate of 10 GPM and a piston area of 7.06 per square inches, the extension velocity would be 327 inches per minute. Velocity extension can be multiplied as determined as 231 into 10 by 7.065 inch square. And power, which is a very important parameter, what the power to be produced by the hydraulic cylinder, that is the power P can be given as force multiplied with a velocity phi. The P in kilowatt can be given as force in kilowatt multiplied with a piston velocity in meter per second, or force equal to pressure P multiplied with the flow rate Q, that is equal to P in kPa multiplied with the Q in meter cube per second. The power is the rate at which work is done, and in hydraulic systems it's the product of force and the velocity, or equivalently pressure and flow rate. Example, if a cylinder exerts a force of 51,000 pounds and at a velocity of 327 inch per minute, the power would be 16,689,000 pound inch per minute. That is P equal to 51,000 into LBS multiplied with a 327 inch per minute. Like this, we can calculate the power of the this hydraulic cylinder. And this is about the hydraulic cylinder force, velocity, and power. How you can calculate if you know the piston area as well as the flow rate and the pressure what will be acting on the hydraulic cylinder during the extension and the retraction stroke. Thanks for watching. If you like, share, subscribe, and comment.